The program examines regression diagnostics, focusing first on heteroskedasticity and multicollinearity. These issues arise when the assumptions underlying classical linear regression are violated, potentially reducing the reliability of statistical inferences. Heteroskedasticity occurs when the variance of regression residuals is not constant across observations. In financial datasets, this problem is common because volatility often changes over time, particularly during periods of market stress or economic instability. When heteroskedasticity is present, ordinary least squares, OLS, coefficient estimates remain unbiased, but standard errors become unreliable, leading to inaccurate hypothesis tests and confidence intervals that may distort financial conclusions and risk assessments. The program explains that heteroskedasticity can be identified through residual analysis, statistical testing, or patterns in plotted residuals. A common indication is that residual variability increases or decreases systematically as the explanatory variable changes. In finance, heteroskedasticity frequently appears in return series because market volatility tends to cluster over time. The program emphasizes that ignoring heteroskedasticity may result in underestimating or overestimating the statistical significance of regression coefficients. To address this issue, analysts may apply heteroskedasticity consistent standard errors, weighted least squares, or transformations of variables. These corrective techniques improve the reliability of regression inference and support more accurate quantitative analysis within portfolio management and financial risk modeling frameworks. Another major topic is multicollinearity, which occurs when explanatory variables within a regression model are highly correlated with one another. Multicollinearity does not bias coefficient estimates directly, but it increases the variance of those estimates and reduces their precision. As a result, it becomes difficult to determine the individual effect of each explanatory variable on the dependent variable. In finance, multicollinearity is common because many macroeconomic and market variables move together, such as inflation, interest rates, and economic growth indicators. The program highlights that high multicollinearity may produce unstable coefficient estimates, unexpected coefficient signs, and weak statistical significance despite a model having strong overall explanatory power. The program discusses several methods for detecting and addressing multicollinearity. Analysts may examine correlation matrices, variance inflation factors, or the sensitivity of coefficient estimates to changes in model specification. When multicollinearity is severe, potential solutions include removing redundant variables, combining related variables, or collecting additional data. The program stresses that multicollinearity primarily affects interpretation rather than prediction accuracy. Consequently, the importance of correcting it depends on the model's objective. In financial applications where understanding the impact of individual risk factors is critical, addressing multicollinearity becomes especially important. Effective management of this issue improves model transparency, interpretability, and the reliability of quantitative financial decision-making processes. Topic focuses on model specification, which refers to selecting the appropriate functional form and relevant explanatory variables for a regression model. Proper model specification is essential because omitted variables, incorrect functional relationships, or irrelevant regressors can lead to biased or inefficient estimates. The program explains that omitted variable bias occurs when an excluded factor influences both the dependent variable and included explanatory variables. Conversely, including irrelevant variables may reduce model efficiency and increase estimation uncertainty. Financial models must therefore balance simplicity with explanatory completeness. Accurate specification is especially important in risk management because poorly specified models can produce misleading forecasts, underestimate exposures, and distort strategic investment decisions. Overall, topics emphasize the importance of diagnostic testing and careful model construction in regression analysis. The program demonstrates that even well-designed regression models may produce unreliable results if key assumptions are violated or if models are incorrectly specified. Heteroskedasticity and multicollinearity can distort inference and interpretation, while specification errors may generate biased conclusions and weak predictive performance. Financial analysts and risk managers must therefore evaluate regression outputs critically rather than accepting statistical results at face value. By mastering regression diagnostics and model specification techniques, candidates develop stronger quantitative skills for building robust financial models and making informed decisions in dynamic and uncertain market environments.